Okay, the general angle and related acute angles. So with these, we're basically combining the last two videos and putting them all together in one. So let's start off by talking about just the acute angles to begin with. Okay, so here is my circle. Actually, you know what? I'm going to do it this way. I'm going to start off by drawing a circle in a Cartesian plane. Okay. And we're going to talk about our little individual parts again, okay? So we already know that if we take a ray and push it up through here, and it intersects at a point at theta, okay? So here's our point here. And let's say that this is 30 degrees, okay? So what we talked about before is that that would be the same as if I was to have 30 degrees in here. And we decided that, well, if that is equal to 30 degrees, so this one over here is 30 degrees, then this one over here is 150 degrees because it's 180 minus 30, okay? So with that being said, we can use that fact to determine, well, what are the sine, cosine, and tans of, say, like 150. So just really quickly, and tan of 30 degrees. Okay, so going back over our exact values, so remembering that our exact value for sine is 1/2, our exact value for cos is equal to √3 on 2, and our exact value for tan is equal to 1 on √3, or √3 on 3. Okay, so with that being said, we decided that 150 degrees is the same as, or its related acute angle is the same as 30 degrees. So realistically, that should mean if I put sine of 150 degrees into a calculator, cos of 150 degrees into a calculator, and tan of 150 degrees into a calculator, I should get the same results back out. Okay, so let's start off with the first one, sine of 150 degrees. So we put sine of 150 in, and it turns out, well, that's also equal to 1/2. So that seems like a really good sort of starting point. But then we put cos of 150 degrees in, and we get this answer that almost looks the same, but with one subtle difference. There's a negative in front of it. Okay, seems odd. But let's try tan as well. So tan of 150 degrees is also equal to the negative of √3 on 3. Okay, so it turns out that sine will give the same result back. So in fact, we can conclude, so sine 150 degrees is equal to sine 30 degrees. But the other two aren't true. So why is that? Well, going back to our sine of a trigonometric function, remember, we worked out that all stations to Central, or all stations to Coaldale, give us or tell us what our trigonometric ratio is going to be. Is it going to be positive or negative? Okay. So the only thing that should be positive in the second quadrant are all of our sine values. So if I do sine of 90 degrees up to 180 degrees, not including those two, I should get a positive value back. But the other ones are going to give me this negative value. So the negative √3 on 2 and the negative √3 on 3. Okay? So why is that? Well, sorry, not why is that, because I just showed you why. Because we worked it all out already. We worked out that sine, tan, and cos have specific quadrants where they're positive. So how do we make them equal? Well, if sine of 150 degrees is equal to sine of 30 degrees, how can I make cos of 150 degrees be equal to cos of 30 degrees? So what can I do to this to make it equal to cos of 30 degrees? Okay. Well, how do I change negative to a positive? It's pretty easy. I just multiply it by -1. So cos of 150 degrees is equal to negative cos of 30 degrees, okay? So why this is useful is because we already know what the exact values are of cos of 30 degrees, cos of 45 degrees, cos of 60 degrees. But we can now work out what cos of 150 degrees is, cos of 135, and cos of, I want to say 120. So we can work out those new ones by just changing it so that it is the negative of either 30, 45, or 60. And it's the same for tan as well. So tan of 150 degrees is equal to negative 1 lots of tan of 30 degrees. So tan of 150 degrees is equal to negative tan of 30. Okay? So what we've got is these general angles, okay? So I'm not going to go through and do the other two because it's pretty much the same thing, okay? It's just repeating this same thing, but obviously in the third quadrant, it's just tan that becomes the positive one, and in the fourth quadrant, it is cos that's the positive. Okay, so what we have are these general forms, okay, that we can write out that will more or less tell us how to get that obtuse angle and find what the exact value of it is, okay? So if we want to get, so if we have something that's between 180 degrees and 90 degrees, what we can do to find the sine of it, so sine of 180 degrees minus the angle that we have, so this is basically saying, 180 degrees minus this 30 degrees that's sitting here to get us to 150 degrees. So the sine of 150 degrees, so 180 minus a, is just the same as if I was to do sine of a, or sine of 30 degrees. So sine of 180 minus 30, so sine of 150, is equal to sine of 30 degrees. The cosine of this, so 180 degrees minus a, is equal to negative cos of a. Okay, so what this one is saying is, say I had my angle A was 30 degrees. 180 minus 30 degrees is 150, so cos of 150 degrees is equal to negative cos of 30 degrees. So if you can work out what cos of 30 degrees is, cos of 150 is just the negative of that. And similarly, I can't even say that word at the moment, tan of 180 degrees minus that angle is just equal to negative tan of that angle. Okay, so just like we said up here. Now continuing this, why can't I say regular words? Continuing this pattern, okay? So our next one we're going to be talking about are the angles down here, okay? So for my 30 degrees down here, what I need to do is I need to take this 180 and I need to add the extra 30 degrees to get to my 210 degrees, okay? So my sine of 180 degrees plus my angle this time is equal to, and the reason I'm doing 180 plus is because this A here is representative of the angle that I'm using, okay, in that acute, or that related acute angle. Now, sine in the third quadrant is negative, so sine of 180 degrees plus A is just equal to negative sine of A. Okay, that's considering that A is between 0 and 90 degrees. Okay, cos of 180 degrees plus A is equal to negative cos of A. And this is the one that's different, so tan of 180 degrees plus A is equal to just tan of A. So say, for example, if you had tan of 225 degrees, so 180 plus 45, well, that's just the same as tan of 45, which is 1. Okay, and you can check that too. If you put tan of 225 into a calculator, you get 1. Okay, which is the same as tan of 45 in a calculator, which is also 1. Now, quadrant 4, our last quadrant. Okay, doing the same thing. So this time it's going to be sine of 360 degrees minus our angle, because if I was to draw my 30 degrees in, it comes from this one down here, and I'm subtracting it, okay? So remember, if I'm going backwards, I'm subtracting. If I'm going forward, so if I'm going anti-clockwise, I'm adding. If I'm going clockwise, I am subtracting. So my quadrant 4, sorry, so sine is negative. Okay, cos in this case is positive, so that's just equal to cos of A. And then finally, tan of 360 minus A is equal to negative tan of A. Okay. So basically, using these using these quadrants and applying them with the trigonometric ratios and the acute angles, we can actually now determine what are the values, or what are the exact values for numbers that are larger than 100 or 90 degrees. Okay, so the ones that we're going to be mainly focusing on are, again, the ones that are linked to the acute angles of 30, 45, and 60, because those are the exact values that we know. But with that being said, it's just such a useful skill to have, because we can then simplify a lot of things in a lot of ways that we couldn't before. So let's have an example of what this looks like. Find the exact value of sine of 300 degrees. Okay, so sine of 300. So first we need to decide, well, what quadrant is sine of 300 degrees in? Well, 300 is between 270 and 360. So this is in the fourth quadrant. Okay, so the rule for the fourth quadrant is sine of 360 minus our angle is equal to the negative sine of that angle. Okay, so what do I need to subtract from 360 to get to 300? So in other words, 360 minus what is equal to 300? And hopefully you got that. That's not right. A must be equal to 60. So sine of 300 degrees is equal to negative sine of 60 degrees. Now, going back to our exact values, we know that sine of 60 degrees is, so sine of 60 degrees is equal to root 3 on 2, and that's using our exact values. So we know that sine of 60 is equal to root 3 on 2, but sine of 300 is equal to negative sine of 60. So that's just negative root 3 on 2. And that's it. We've got an answer in terms of an obtuse angle. Okay? So sine of 300 is equal to the negative sine of 60, which is equal to the negative sine of root 3 on 2. Okay, let's continue on. We've got cos of negative 210 degrees. Okay? So what we need to do is we need to work out, well, where the hell is this? In which quadrant is 210 degrees? Okay, to work out what the related angle is before we, the related general angle is before we do the related acute angle, we need to work out, well, what is this between 360 and 0? So what we're going to do is we're going to add we're going to add negative 210 to 360. So we do minus 210 plus 360, and that gives us 150. So this is the same as cos of 150 degrees. Ooh, why aren't you doing what I want? So between 0 degrees and 360 degrees, okay? So we need to make sure it's between those three first. Now, cos of 150 degrees is in the second quadrant, okay? Because it's between, so it's not between 0 and 90, but it is between 90 and 180, so it's in the second quadrant. Okay, so cos of 150 degrees, okay, well, we do 180 minus 150, which means that is equal to 30 degrees. Okay, so 180 minus 150 is 30 degrees. Or what I should be saying, actually, is we should be using our rule. We should be doing this the proper way. Okay, so in the second quadrant, my cos rule is cos of 180 minus A is equal to, okay, so cos in the second quadrant is negative. So cos of 180 minus A is equal to negative cos of A. Okay, so in other words, I'm asking you, 180 minus what is equal to, in this case, it's 150, and we should get that A should be equal to 30 degrees. Okay, so cos of 150 degrees is equal to negative cos of 30 degrees. Okay, so we know that cos of 30 degrees is equal to root 3 on 2 as well. Okay, so cos of 150 degrees, let me try that again, and I'll put a degree in there. Cos of 150 degrees is equal to negative root 3 on 2, just like we had before. Okay, and finally our third one. So our third one in this case is our cos of 570 degrees. So cos of 570 degrees. You know what? Let's change it up a little bit. Let's do tan of 570 degrees. Okay? Do tan of 570. So, to do tan of 570 degrees, we need to work out, well, where is 570 degrees in the... whereabouts is it? So how many revolutions past 360 is it? I think it's only one, because so between 0 and 360 is one revolution, between 360 and 720 is the second one, 570 is between there. Okay, so what we're going to do is we're going to do 570 minus 360, and that's going to tell me that tan of 570 degrees is the same as tan of 210 degrees. Okay, tan of 210 degrees, well, whereabouts is that? 210 degrees is between 180 and 270, so this is in the third column. So this is in the third column, or sorry, column, not column, quadrant. Quadrant, let's use the proper terminology. Okay, so in the third quadrant, so quickly draw up my sketch if I can't remember, all stations to central, the third quadrant is T. So that means tan's going to be, so tan of 570 or tan of 210 degrees is going to be positive. And I just quickly forgot to actually finish off my question. I didn't want to know what cos of 210 degree, of 150 was. I want to know what cos of negative 210 was, which is just the same thing. Okay, so tan of 210 degrees is in the third quadrant. It's going to be positive, so we know that tan of... So in the third quadrant, my rule is 180 plus the angle is equal to the positive of that angle, okay? So in other words, I'm asking 180 plus what is equal to 210 in this case. And hopefully we get that A is equal to 30. So tan of 210 is equal to tan of 30 degrees, okay? So using our exact values for tan of 30 degrees, we should get that tan, so tan of 210 is just equal to the positive root 3 on 3. So if tan of 210 is that must also mean that tan of 570 degrees is also equal to root 3 on 3, just like that. Okay, so nothing too different about these ones, okay? It's just applying a new rule kind of thing to this, okay? So, you know, we're still using exact values, okay? But we're just doing it with angles that are bigger than what we're used to. So practice those exact values, and then this will be really, really easy. I'll see you guys in the next one.